Okay, kids, we're going to finish off the example we had started in class. Where we left off was questioning whether our horizontal asymptote was going to get crossed by the graph of the function. And what we determined in class was if it does, it will be at a point that has the same y coordinate as that horizontal asymptote. So we set the function equal to the value of our horizontal asymptote, which we had found in class, which was 5/3. And we were going to solve this equation. If we get a number that makes sense, that will be the x-coordinate of our point of intersection with the asymptote. If we get something that doesn't make any sense, there won't be any crossing. So we had decided to use cross multiplication as our solving technique, and we got that 15x squared minus 20 equals 15x squared plus 3. When I do this and subtract 15x squared from both sides, we get that negative 20 equals 3. This is something that doesn't make any sense. So the implication here is that our graph is not going to cross the horizontal asymptote. All right? So that brings us back to what we have so far. What we have so far is a horizontal asymptote at 5/3, our two vertical asymptotes. We have our y-intercept, and we also know we have no x-intercepts. So now it's a matter of making this graph. Now, what I can do for the middle section of this graph is I can say to myself, if I focus here for a moment, I know that I'm not going to cross the vertical asymptote. I know I'm not going to cross the horizontal asymptote. I know I'm not going to cross the x-axis. So the only way the graph could look in here is to have some sort of parabolic type shape within the constraints of the x-axis, the vertical asymptotes, and goes through my y-intercept. And that's just kind of just from logic. I'm going to get rid of that highlight there. For the other parts of the graph, the left side and the right side, in this particular case, I can logically think my way through it. Over here, this half plane, what's going on? Well, remember that I'm not going to cross the vertical asymptote. I am not going to cross the x-axis, which means the only option is that my graph will exist here. If the graph had existed below, we would be treating the x-axis as an asymptote, which would not be correct. Or if we did treat the asymptote correctly, I would be creating an x-intercept that we know doesn't exist, and that would be a contradiction. So we can't do that. Similarly, for the left side, I have no x-intercept. I have no crossing of the horizontal asymptote. So once again, my graph, the function, must exist in this region. Let me get rid of that highlight. Let me get rid of those circles. And now we have a complete graph for the function that we started with. In the event we could not have logically determined where the ends of this function existed, we could have chosen some test point, choosing some x value from either of the half planes and gone a little bit old school with a plug and chug, choose a value for x, calculate a value for y, plot it appropriately, and fill in the graph from there. All right? So that finishes off our example from class, and I will also give you some other examples to look at as well. All right, hope that helped. Bye.